To another episode of the New Old Computer Show. This is the second part of the Lisa series. So today we are gonna get back to trying to get a functioning Lisa. Let me get the camera over here and see if we can take a look at her. The camera is on. Let's see if the capture device still works. Maybe not. As always, yeah, probably need to just switch it over again. There we go. Let's adjust it a little bit, maybe like so. So this is where we left Lisa off last time. I put the power supply back in, but yeah, she's pretty empty at the moment. And quick recap from last time. My mission right now is to build a new version of this, which is the motherboard. If I can get it to focus. Can it focus like this? Come on. Camera doesn't like to focus. It must be really locked hard on this scene over here. Sometimes I don't understand the logic, but I'm pretty sure it's. I think I talked about this last time, but I'm pretty sure it's an autofocus, so I'm not sure why it doesn't want to do that. Anyway, I'll learn more about this camera eventually. But yeah, I need to rebuild this battery damaged motherboard. For that purpose, we have this replica that is now partially built. And I think a nice little thing that we can start off, a little note that we can start off on today is that I got a little bit of a goodie in the mail. Actually, it's this package sitting here. This is now a rarity, I think we could say. At least the seller told me that this is maybe the second last one in existence. And the seller is, or the sender, yeah, seller and sender is Vintage Micros, which is a old school purveyor of tech for old computers, and they have a bunch of Lisa products in stock. I don't think this product in here is actually listed for sale anymore, so I just reached out to the owner of the company and asked if he could track down some down for me, and he did eventually. Actually, I sent him the message in May, and he got back to me a couple of weeks ago. So it was quite the wait, but well worth. So I already opened it up just to see that it was intact. So I know what's in here, but let me share with you. We don't need the invoice. So let's start right away with the spoiler. So we have the printed material. Seems this is just a piece of paper. I guess it's the cover. It's the cover of the manual, so to speak. Quick boot. It's the X/Lisa quick boot device. I will explain in a minute what it does. And this was also to give you the spoiler what it's what it's all about. It's a little device, or basically it's a ROM. And some more printed documentation. And then the important part, I think, is in this little box here. Interestingly, it's been cracked open once and then taped back together, so I guess it's a recycled box. Let's open this back up again. And inside we have an anti-static bag with something inside, and a double-sided, double-density floppy disk, very fancy yellow, with the software on it. So look at the bench. Let's see, I'll protect this. The protection in. So this is sealed, so let's open it up. See what's inside. If I can find my scissors. Here we go. So let's open this up. And here we go. So I believe people who know the Lisa, they're well familiar with this thing here, but now the focus is terrible, of course. So there it is. It's probably hard to. There we go. The label says SBR version 1.2a, copyright 1992, Query Engineering Inc. And it's a little logic chip on top of a ROM chip with a little bodge here. And that's about it, I think. And also a little bodge here, or a little pin. Those two pins are soldered onto the host's ROM chip there. So this is a very old school device in the sense that it's two chips that are bodged together. That was more common in the early days of whatever, computing, the early days of computing history, where everything was more DIY and a little bit messy. This is the Lisa Quick Boot. And I also actually have the thing here where it goes. Here is a Sunray Marketing made SCSI board for the Lisa. So it has the Sunray Marketing label there on the ROM chip. A DB25 for the SCSI. A 50-pin header for the SCSI. And it's not too much happening. The SCSI controller, I see some logic, some old school ceramic package, which is cool, and a Molex connector. And my understanding is that this chip goes right into the socket instead of the stock Sun chip. And it simply gives this controller board the ability to boot a Lisa into Mac XL. So basically boot into Mac OS from a SCSI device, SCSI hard drive, basically, which can be handy. I don't think the profile, the stock Lisa hard drive, supported booting into Mac OS from it. You would boot from floppy disk, which we did last time, most likely. But with this little setup here, you can turn your Lisa into a permanent Mac XL pretty much, and don't worry about the Lisa OS or the profile. So I thought it was neat to potentially get this set up. I did play with this SCSI controller quite a bit before the Lisa got sick again. But there it is. So I'm gonna put the Lisa quick boot back into this little case, little baggie, and hopefully if I get the Lisa working soon, I can actually try this. That was just a little intro. We should probably get back into getting this thing working. So I promised I would be better prepared this time. I kind of am. I've been able to sort out some components that are due for this motherboard build, and I have got another few baggies over here ready to ready for the logic board, IO board build eventually. But I need to do a little bit more sorting because it's a lot to sort. So since it's still pretty slow here, I don't know if anybody's watching or not at this point. I guess I should just keep sorting until things get interesting. I'm gonna throw this stream. I forgot to promote the stream in the Tinker Different Discord, so I'll just do that right now. So what I have here is, of course, this whole baggie full of box here full of baggies that need to be sorted out. Let's see, I should turn off the camera. Save battery. So I'm just gonna switch over to the PC screen. Let me. I'm gonna put myself up on the side here. Let's add the video capture device. I think it's webcam 1. Yeah, there I am. So oops. So this is what I was looking at. So basically I'm painstaking. So in hindsight, I should have gotten these two carts separately, but I wanted to save on shipping. So I combined them into one order, which means that they come not sorted, and I should not have done that. I should have just ordered the two carts separately and paid the $10 or whatever shipping. That would have saved me a bunch of time, because now I have to sort this, which is annoying. And also I'm gonna, let's see here. Interesting. I'm gonna see if I can watch my own stream live, and let's see if I can, let's see here. Oh yeah, now I can see myself live. I need to turn off the audio. So at least I can see if some live chats are coming in. But yeah, let's get our hands dirty and wrap up this sorting. So I don't know if there's a better way to do this. But I basically just search the product key on the cart on the back compared to the cart, and then I know basically which pile it should go in. So for instance, this component here is a resistor 1.5 k ohm, and it shows up in the motherboard cart, so that's where it goes. So yeah, this is not a super fun process, but it's gotta be done. Next one is 399, 454, 1ND, yep. That's the motherboard. Next one is CF14J. Yep, CF14J. Okay, it's not in neither, so that could be a replacement. Let's see, 330 k ohm. Yeah, it's probably one that I got as a replacement. 330 k ohm. 330 k ohm. Yep, that's most likely the I/O board. And then we have the next bag here is EC511. EC511. Okay, it's not in either. So it's a 10,000 picofarad. Pico, not pico. Pico, right? Weird. Oh, so this is probably yet another replacement. A radial 10,000 picofarad. So is it 0.1 microfarad? Yeah, that's probably it right there. Yes, I'm pretty sure. Oh yeah, this might have. Oh wait, those are axial, and these are radial. Okay. These are also axial. So what, did they send me radial caps instead of axial caps? That's kind of annoying. Let's check if the original board has radial or axial. It's definitely axial. So well, they're not the worst, I guess, components for this purpose, but it's a bummer that maybe that was one of the sometimes they do automatic replacement for cheaper parts, and this is maybe the case where that replacement wasn't ideal. Anyway, moving on. 324 KX PXKND, yep, that's the I/O board. 10K ADCT, that's also the I/O board. 150 QB K-ND. It's also the I/O board. 3.3K KQ 3.3K Q. Interesting. Okay. 3.3K ohm axial cap. Oh, sorry, resistor. But it's different from what's on here, but I think that's the correct one. That is the motherboard. Oh, hi Brenda. I'm yeah, it's been a very long time no see. Thanks for coming over earlier. I'm doing fun component sorting time here because I was silly enough to order both carts into one combined order. So this goes to the I/O board. Next one is 1N4148 FSND. Yes, this is also the I/O board. The next one is 1514. Okay, it's not here. 1514. Happy transistor. Yeah, that's the one that goes to the motherboard. Next one is 1572. Capacitor. I already installed this one, so that's an empty bag. Next, 40.2. KXCTND, and that's the I/O board. Next up, 13CFR 25R52, etc. No, this is a different one. 100 RCT, resistor 100 ohms, and that's the motherboard. Okay, Brenda says DigiKey packages all look the same. You can label stuff in the order and they'll print your labels on the individual packages. That's good to know. I'll do that next time. I didn't do that this time. I guess it's kind of uncommon for me to do this kind of this large of an order. I usually do pretty small projects. So I haven't made use of their sort of at scale project features. So that's the motherboard. Here we go. Some caps. 1572. Yep. No, it's 1035. 1035. Yeah, those caps go on the I/O board. And then we have sockets that are pretty bent. But sockets I just put in a different pile, that's fine. This cap, I'm pretty sure this is the I/O board. I recognize it's 1189. Yep, this 100 microfarad cap that goes on the motherboard. And then I have 399, 399, 399. Interesting. These are ceramic capacitors. 27 picofarads. Sorry, 27 picofarads. Yep. That's the I/O board. And then we have some IC gate NAND 4-channel 2-pin 14 DIP SN47 74 LS132 LS1 LS132N. Yeah, so that goes on the motherboard. Then we have Zener diodes. Definitely, yeah, that's what I thought. That one goes on the I/O board. Then we have some resistors, 20K, PK, QB, K, and D. 3 of them. That goes on the I/O board. And then we have 15OH and D. Another big cap goes on the I/O board, and then we have a little switch that I know for a fact goes on the I/O board because it was pretty badly battery damaged. I remember that pretty clearly. MFR 25FBF 22K 22K ND. Yeah, that's the one. It's the I/O board. Then we have 75 QBK, 75 QBK. It's a 75 ohm resistor that goes on the motherboard. And then we have 244. It's a trimmer, so like a potentiometer, I guess, for adjusting resistance or something. No, it's actually a capacitor, right? It's adjusting capacitance with the potentiometer. So that goes on the logic I/O board. Okay, here we go. So these are the axial caps. That's more like it. So we do have the 0.1 microfarad or 10,000 picofarad axial caps, and I think they go on both, was the conclusion. So yeah, let's put them over there. So I don't need the radial ones. And then we have a socket. I think we have all the sockets installed on this, so we don't need more sockets. I think these are all for the other one, the I/O board. Then we have a two resistor arrays. I'm pretty sure these are for the serial ports on the motherboard. Array resistance array. Yep. I'm familiar with those. I have ordered those for the other one because they are the ones that the battery juice drip onto and completely destroy. And 330Q, BK and D resistor goes on the I/O board. Then we have a bunch of inductors. Those are cute. I like how these look. Little black packages. I'm pretty sure these go on motherboard. Fixed inductors, 10 of them here. And then we have 5.1K, 5.1K, yep. I/O board thing. And then we have 80.6 kilo ohm, one of them, yep, that's another I/O board thing. And then we have 2 resistor arrays again. Interesting, so they must go on the other one then, I guess. These are the 3. Oh, wait. So I got the 2 mixed up. Maybe. Interesting. So, oh no, these are the something different. We'll get there. We'll get there. 56k ohm. Yeah, these were the ones that I wanted to put on the motherboard. And then we have a 1.0 K QBK and D. 1 kilo ohm resistor goes on the motherboard. And then we have a bunch of 1k ohm, 1.0 K QBK. Wait, so these are the same? How cute. So it's same component but in two different bags. So I guess I got that messed up. Sorry about wasting the picker's time and wasting a bag. Because yeah, these are the same. I just need the one for the IO board, so also the motherboard, so we can put that there. And then we have the final baggie. Final baggie, 39k, 39k, QBK, 39k ohm resistor. All right, cool. So the bag's empty. I think that means we have everything that I need for doing the build. So the IO board components go back in the bag, back in the box. I do think all of, or most of these other, these are just sockets and connectors, connector IC dip, and then all of the long tubes of IC sockets. So let's put them down there. All right, now we can get back to actually doing the build, which is super exciting. So I have what I think is all of the requisite components hanging out here. This is all that we need, hopefully, more likely. And let's see here, put this aside. We have some more stuff in here, but yeah, maybe we need that, but we'll figure that out. Oh, actually, probably better check these baggies too. Oh, here are the resistor arrays that I mistakenly thought should be on the IO board, the motherboard. So let's go do another quick look at these lists just to make sure that we have everything else correct. This array 3.3 k ohm, yep, that goes in the IO board box. And then we have a push button. Push button is definitely for the motherboard, but let's check. Push button, yep, that's that one. You probably want to install that because it's handy to be able to reset the computer. And then we have 69k, 69k, oh 698x, okay, that's why. That goes into the IO board, and here's a crystal 3.93. Oh, interesting. Oh, there it is. Oh, it's 3.93 crystal megahertz. We have trans kinky right over here. Oh, interesting. 2SA. 2SA. Wait, did they send me the wrong transistors? That would be a bummer. Or did I order the wrong ones? Yeah, because what we need is... Oh, wait. Oh, yeah. That could have been my mistake. Let's put them on the side here. That might be a problem. In the worst case, we'll just steal the components from the original board for sure. The other crystals are all on the iron board, I think. Crystal. This is the 16 megahertz one. Yep. This is 1.5 ohm, kilo ohm. 2N39 transistor 04 FSND for them. Oh, interesting. It's only one in here. Is that the same over here? 2N39. Yeah, this is the one. No, wait a minute. It's 3N90. Huh. 40 PMP. Oh yeah, this could be a substitution, potentially. Put that on the side here as well. I think there were some transistors that I had to substitute, and I'm not an expert on substitution, so I could be making mistakes. 1.0 NQ BK ND, 1 mega ohm resistor goes into the IO board, and then the crystal IO board, and 68K ohm. Sorry, 68 ohm. Also the IO board, and then a big bag connector these up, which we don't have to install right now. That's for the motherboard, I think. Okay, let's put that over there too. And these go into the IO board bag box. Cool. Finally, now we're ready. It's only 38 minutes into the stream, and we can start assembling this thing. So for this job, let's see if I can. I think I want to try to create a browser share. It's messy when I use the it's messy when I use the whole screen share. So yeah, there we go. So this is too big. Something like that. Then maybe I can put myself in the corner as well. Okay. So the instructions said to basically refer to the schematic to understand which components go where. So that's what we should be doing. Let's actually, can I make this smaller? Oh, it may. Also scales the image, maybe like that. Okay, great. So now I can watch chat while I look at this screen. That's much more convenient. All right, turn on my iron so it can heat up a little bit. So let's see here. Let's start with, I know there's just one more big electrolytic capacitor that needs to go in here. I'll just install that for simplicity's sake. So it's just this one. Goes right here. Of course, electrolytic caps, you have the negative lead on the band there, so let's put it in like so. Turn on the fume extractor. Easy first components. Let's go back to the browser. So, so basically what we get here is the labeling and value of everything that we need to attach. Actually, let me close my cabinet door or my closets. Yeah, I'm always eager to go in and solder, and then it's like, yeah, it's smelly. Get all the fumes in your face. So I think what I do want to get all these components soldered because it's kind of tight here. So O1 and O2 could be good starting points. If we can find, let's see, can we do a search? O1, can we find O1? It's really hard to see. They're somewhere on here. Oh my gosh. This is where it's nice to have a bomb with the labels. And I'm sure there is one. Maybe I should search for Lisa motherboard bomb. Lisa 1, that's not what we have. This is the motherboard, the Lisa motherboard. Oops. Aha, cute. That's an original schematic for the motherboard. Yeah, it's probably easier to work with the reverse engineered one. Let me see, maybe if no. Can you all find O1 and O2? Q7, Q1, is it Q? Oh, it's Q. Of course. Of course it's Q. These are transistors, yeah. It's the 2N4258. Which I might not have the right variant of. but I have this. Let's look at I have this transistor kit. See if we have the exact same ones in here. 2N4258. Nope. Oh, I'm talking about it's the motherboard. On the Lisa, the motherboard is the interconnecting board. It doesn't have much logic by itself, but it just takes the signals that's coming from the memory boards and the CPU board and the I/O board, and just connects it all together, and then it has the I/O here, serial, mouse, parallel, video, composite video, and the expansion ports. So yeah, anyway, yeah, it is very modular. So Brandon, maybe you missed the previous stream when I started out the first hour or so. I showed off everything and kind of explained how the Lisa is put together, the different boards that come in and out, and yeah, it is very modular. So it's a neatly designed computer. Okay. I/O board. Interesting. Am I looking at the wrong schematic? Oh yeah, I'm looking at the I/O board schematic. That's why I'm confused. Sorry. Haha, that's alright, Brandon. You can always rewatch it. It's early on in the video when I went through everything. But anyway, I threw myself off by looking at the motherboard schematic. Sorry, the I/O board schematic when I need to look at the motherboard schematic. And yeah, the 2N4258 transistors are discontinued parts, so those you have to either source from eBay or AliExpress or steal from the donor board. Yep, that was a bit of a false start. So let me, I'm gonna go back to the browser. See here, here's the motherboard schematic, which is a lot easier. I was thinking it looks very this looks very complicated for the I/O board. I didn't think there was so much logic, and yeah, very accurately, yes. This is what we need to look at. Yeah, that's right. And the I/O board doesn't actually have I/O on itself, but it's just handling all the I/O, the disk controller stuff, basically, as I understand it, and I guess logic for the serial and parallel mouse and everything. So it's just all happening on this board, and then all the signals just come and go on the edge connector and to the connectors, to the D sub connectors on the motherboard. So we just got some ROM chips up here and controllers. Yeah, I think it's fair to say that nobody really tried to design a computer like this again. A bit of a dead end, maybe. Q1. So I wish searching in a PDF would give you a little bit of highlights, because I want to know where Q1 and Q2 are. Oh, there. Okay. It's a very faint green highlight. So yeah, we need 2N3904 for Q1 and also 2N3900. Oh, it's different. Okay, so Q1 is a 2N3904. 2N3904. So that's maybe the one that we don't have. So Q2 we have. That's 2N3906, which I have right here. So we can install Q2 at least. Here it is. So let's get that into Q2. Yeah, this is interesting. The walls had nothing to do with this design, supposedly. That maybe he snuck in and did some tinkering when nobody was looking. Snuck in. So the other transistor that I ordered for this build is 2N39. Oh, well, interesting. So I did order, well, this is not the actual order. I should probably, let me, I'm gonna check my order. Two and 3904. 2 and 3904. Oh, it's multiple pages. Yeah, don't worry. I don't think the was part of this. The Lisa was famously or infamously designed by committee, I believe. Oh, that's annoying. Yeah, I definitely ordered 2 N3904s. 2 N3906. Oh, here's another bag with 2 N3906. Such fun. 2 N3906. Oh, okay, they go on both. So this goes. Oh, so maybe that's why I may have put both transistors. Oh no, wait, is this one? This must be the one. 2N3904. Yeah. Good. Right there. Good, good, good. All right. Good. Interesting. They installed that transistor the wrong way around. Such a smooth start to this stream. Definitely did. That's more like it. Yeah, so it should be in the other way. Oh jeez. So at least I got the second one installed the right way. And then let's desolder the first one. There we go. So polarity of transistors is important, so don't do what I do. Alright, back on track. So, let's see what we can do next. Back to the browser. I wonder, it's gonna be kind of a long process to go one by one with all these resistors. That would be annoying. If you all have a good idea what I should be doing, let me know. Now I'm looking for resistor 1. Oh my gosh, this is annoying. There's R12. Oh, R1's not by the parallel port. I could look at the parallel port. Serial is here, be parallel here, no? Okay, R1 is not connected to the parallel port directly. It's somewhere else. R14, C14, R15. There's R1, okay. It's 1K. On the 1KL. So I think I'm gonna. So when you do these through-hole soldering projects, you can always put on a bunch of them and then fold the legs and then kind of solder them later. That makes it easier to adjust for mistakes as well. I think I'll do that. And so all these resistors are going to be such a pain to find. Oh my. Oops. can always try the opposite and search for the values. So, for instance, we have 75 ohms. Where is that? 75 ohm. It's just giving me pin 75 on these ICs. There it is. Okay. R2 75. Okay, this is R2. Okay. I guess I was fairly helpful to do it like that. Next up, 10 ohm. How can you find 10? There's gonna be so many 10s here. It's gonna be impossible to find a 10 ohm resistor. Oh no. I guess you could just write the values here on the silk screen. That would be handy. Let's do the 10 ohm later. 100 ohm. 100 is also gonna be impossible to find. It's just too many hundreds. Pin 100. Pin 100. Oh, C11 is 1000 microfarads. C 100 microfarads. Oh, there it is. R15 is 100 ohms. Okay. Oh, there are several of them. Several. 3 of them. R15 sits over here. And the next. R6 is 100. And next. R5 is 100. Okay. Not too bad. Okay, let's keep doing that strategy. I need to find 3.3k ohm. So it's at written as 3300, no, 3.3k. Oh, okay. Resistor 13. Resistor 13. maybe I can switch over to the bench a bit so you don't just watch like maybe not the most interesting thing to look at the schematic all the time. System 13 is in here. And then resistor 7 is also 3.3K. And 13, 7. Oh, only 2? Oh, so maybe the last one is for the IO board. So let's put that back into the baggie. And put that behind. And next up we have capacitors. I'm gonna finish all the resistors now, I think. This was 1.5K. Oh, 1.5K. That's resistor 10. Still one. It's 10 right here. Next up is 4.7K. 4.7. That is resistor 8. Next up is capacitor resistor 2.K to 2.7K. 2 of them, yep, 2. So it's 11 and 9. 11 and 9. It's so much smaller for some reason. Kind of messes with my sense of aesthetic for this board. The original board has the same form factor of resistors for all the spots. So it's a bummer that these two came smaller. Next up, 3.3K. I probably should have turned off the fume extractor a while ago. 3.3K, 3.3K. Resistor 7. Interesting. So most of these are actually sitting on the composite out circuitry, which we kind of don't need. But yeah, I guess it's good to have as a backup. R7. and R13. 7 and 13. 7 and 13. Wait a minute. Really? Because we put something else in R7 already. That's that's annoying. Oh, did we have? Maybe that was a different baggie. Yeah. 13. Oh yeah. Yep. We already did that. So that must mean there is 3.3K for a different board. So let's put it back into the 3.3K bag. I'll put it on the side here just in case I got it wrong somehow. 10K on R3. It's only one? Yes, only one. And then we have a 221 ohm. That's kind of a funky value. That's R14 has 1% tolerance. Yes, it says 1% there. That's an unusual resistor. I'm not sure what that is. Goes to VCC on the LS132 chip. Interesting. R14. It's right up here. So you have a bunch more that haven't been populated yet. Right, we had the 10 ohm that was hard to find. There's only the one in there. See if we find it in the composite out cluster. Yes, R4. R4 is 10. R4 is 10. So we do have R12 left to populate. Not sure. R12 is supposed to be a 680 ohm resistor. I think I remember seeing that. 680 ohms. I'm pretty sure that was somewhere. 680 ohms. Maybe that's one of the capacitors that are on both. 680. Yes, there are. One on both. One each on both boards. So I probably had that in the wrong box. 680. So let's find 680 ohms. Resistor 680 ohms, and there's only one in the bag. Oh no, it's 698. Oh, okay, that was slightly different. 698 ohms. Okay. ohms, 1K ohm, 8.6K ohm, 5.1K ohm, 330 ohm, 22k ohm switch, 150 ohm, 20k ohm, capacitor, maybe 60k ohm, 4.2. 150 ohms, 10k ohm, 32k ohm, 330k ohm, capacitor, transistor. Oh, here we go. 680. 680 ohm. There's only one in there. So maybe there are two of them. Two baggies with one each. Not sure. Cannot find. So who knows? But let's build the motherboard. If it's 680k, I think I have a little resistor kit here, which is all a quarter watt. I think that should be fine for this. 680, yeah, I do have 680 ohm. I don't know why even. I should have just used this kit for the resistors, honestly, since it's not a. Oh, I have MK500. Yeah, welcome. We had a bit of a false start with this stream. I had to sort my components before we got right into it, but we made a little bit of progress getting components in place. So that was R2. I need to remind my memory, refresh my memory. 680 R12, yes. There we go. So that's all of the resistors, I think. Let's solder them in place. I think that's a good time to do that. I've lined them up as neatly as I could here. Things looks all right. And there's 3 up there and 1 here. So yeah, let's just go back here to the. See, I guess I didn't leave my iron up. My iron goes into sleep mode after a little while. Of course, I need to turn on the fume extractor now. I think the most labor-intensive part of through hole builds is to snip all the legs off. It takes forever. Yeah. So interestingly, this row of capacitors that are on the composite video output side, they were actually pretty badly corroded too, with the battery leakage. It had the juice had gotten pretty close to them, I think. Alright, that looks alright, pretty good for resistors. Nicely mounts. And here comes the sneaky part. You don't want to sneak these too close to the board in case you need to rework these components. So you want to say just a millimeter each. But you don't want to leave too much either, because then it can short out against nearby things. There we go. Okay, I'm pretty happy with how these turned out. Let's keep going. I want to do the capacitors next. Not too many of them. So we have, for instance, 68 picofarads right here. 68 picofarads. C12 is 68 picofarad. C8. Oh, it's down here. I think these ceramic caps are not polarized, so we can just put it in whatever way we want. Just neat. This is okay. Capacitor ceramic 0.1 microfarad. Thank you for the kind words. I think it looks alright. 0.1 microfarads. So MK500, since you joined late, this is what I've been doing on the side. I'm basically doing a I'm looking at the reverse engineered schematics, and I'm finding the mapping between component label and value. So C13 right here is 0.1 microfarads. So we just need to find C13. Also, I see C14 just above. So 13 and 14. Let's look at these. C14. So I get a bit anal and I always try to adjust these components so they sit just above the little silk screen outline. This makes it nicer to look at the finished job later. And that's it for this one. The inductors here, we take them in a moment. And then a big bag of zero. Oh wait a minute, 0. 1413. Yeah, okay. So I have another bag of 0.1 microfarads, which I think is for the iron port. We have the gate lamps there. We have the resistor arrays. Oh, here's a big bag of 10k ohm, which I think is also for the iron port actually. So we're pretty close. Let's solder the caps. Oh yes, AlexaCat123 has done an amazing job. Very neat diagrams. They only wish it would be slightly more convenient if there was a BOM where you had the mappings of component to label. It would save just a couple of minutes, I think, in assembly time. But it's also a good habit to familiarize yourself with schematics. It's always a bit of a learning experience. You know, we did learn that composite out circuitry is what sits conspicuously over here, like this row of caps here, all on that circuitry, and the video out is over here actually. So that's good to know. And who in their right mind would use a Lisa with a composite monitor? That's weird, huh? I wonder what the use case was for that, maybe just debugging or something? Okay, so let's go do the inductors. There are 10 of them, and I think it's just all of them. L1 through, it's 1, 2, there's no 3 maybe, 4, 5, 6, 7, 8, and 9, 10, 11. Alright, brilliant. So we have one more. I saw this one more cap here, C15. Let's do C15. C15. C15 is 240 microfarads, but I'm using 0.24 microfarads. Oh, interesting. Okay. Is that on the list? 0.4? Nope. 240. Interesting. So maybe we don't have to populate that. I don't know. It's definitely populated, but it's not part of the order. That's weird. Edge connector, IO connector. So we have the 5 volts goes through 1K resistor. So it's just providing ground. for connection between the edge connector and the I/O connector. Huh. Oh, yeah, I guess I should have I should have shown what I was talking about. Yeah, I was just looking at this part here. This is where C15 that we don't have should go, and it's connecting the edge connector and I/O connector to ground. 5-volt supply. Let me see if I have 240 microfarads or 0.24 microfarads in my stash. Two picofarads. Probably not. Also have a box of caps here. It's mostly bigger caps. I don't think I have too many small ceramics. Okay, so I guess that was just one thing that was left off the cart, unless there's a note on that. Let me see if there's a note on that in the instructions. Motherboard. Blah, blah, specials, blah blah blah. Video jack, blah blah. Doesn't mention it. Don't think this is related. Yeah. It's to do the inductors anyways. Here they are. Little black packages. don't think these are polarized either. So I guess in the worst case, I'll just steal that one capacitor, or yeah, one capacitor from the motherboard. Wait, are these? It just struck me. The legs are different lengths on these inductors. So again, I'm an electronics amateur, but on caps that indicates the polarity. But I guess it's not the case here. So I don't see any polarity notation. On the board. Interesting. Yeah, exactly. It's like an LED. Like a true amateur, we can Google it. Are inductors polarized? That was actually the first recommendation. Look at this. So yeah, are inductors polarized? There. Even though inductors aren't polarized in a particular direction, a current flows will change the magnetic poles present in and around an inductor. Inductors. The second most common parts were asked by inductors. Inductors are somewhat similar to resistors, except they are specifically designed for storing electrical energy in the form of magnetic energy. So like I said, they're similar to capacitors in the sense that inductors can be simplified to fancy coiled wires around ferromagnetic material. Inductors do not care which way they are placed, just like resistors, due to the physics, design, and construction. Yeah, okay. So it was a red herring, the length of the legs. Now, interestingly, if we compare with the original board here, there's this staggered layout of what looks like ceramic caps and inductors. And we actually already installed a cap into C. Oh, actually, I see now. This cap should go here. C8 is for the spot next to it. So we need to move that over. Let's solder the inductors first. I think this whole inductor capacitor matrix thing here is this. It's all for the mouse actually. It's quite a number of components just to manage the cleanliness of the mouse signal. I suppose they put that into ICs later, maybe the mouse controller. Touch up a few of these. Now we need to desolder this capacitor here, so we can move it to its correct spot. It's pretty hot, so let's use layers. Out it comes. Now let's put it in the correct spot. And now the legs are quite short. Jeez, this is unfortunate. Wow, this is gonna be tight. This is gonna be very tight. Need to be forceful here. Okay, not too bad. Yep, I have cut the legs pretty short, so yeah, that works all right. Sure. Save the day. And Right, so the final conductor goes into the spot that I just took the cap out of. Okay, and I complained earlier about axial caps that I wasn't sure were needed, but I think those are actually the ones that are supposed to go in between all of the conductors. I need to fish that out of the box. Yeah. If I can find. These ones, 10,000 picofarad, 50-volt caps. Can I have a look at the motherboard? Well, thank you. I'm not. Well, I will be careful to. Oh yeah, right, because I put the cap in the wrong place. That's right. Luckily, this board is pretty darn simple, all things considered. Let's, for example, check C12. C12. Oh, that's 68 picofarads. Anyways. So what I'm looking at here, for instance, so we have inductors here, micro Hubert, is it? And next to them we have these C3, C7, etc., which are 0.01 microfarad, which I think lines up with the 10,000 picofarad that we have on here. Yes. So we know that we need to populate the spaces between all of these inductors with these little caps. Should be good. Okay. Let's just solder all those in. snip the legs. Now I have two legs that have been soldered together, I think, which is never a great idea. But I think this is okay because they are probably connected anyways, but I kind of looks like my stereo. That's better. Just checking for bridges. Fine. Yep, you're right. Sometimes engineers have fun, I think, solving these things. Let's solder the switch. So we can reset the computer if needed. Here's the switch. Keep. Oops. Interesting. Okay, yeah, it goes in like this. Let's hold it down with some glue tack here. I think that some of the neatest PCB layout that I've seen is the Atari 800. It's just incredibly, you can tell that this was, before there was automation around PCB layouts. But yeah, it looked like they had a lot of fun neatly arranging everything. Here you go, switches in. So we only need to find C12 and C15. And then we should be good to test this. C12 and C. So we need to find this 68 picofarad and the, 240 microfarad. Let me, we'll go through this box again. See if we have them in here somewhere. Otherwise we'll have to steal. Diode, resistor. There's a 47 picofarad. That's not it. 47 picofarad. .33 microfarad. Resistor. 3 coils. Ports, dip sockets, 9K ohm, resistor, 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 cap trimmer, resistor, switch, resistor, 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 crystal, resistor, resistor, crystal, connector, crystal, resistor array, resistor, resistor, diode zener, 27 picofarad, it's not 68, 10 microfarads, 160 ohm, diode, diode, resistor, 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 47 microfarads, 47, nope, right, forget, 22 picofarads, diode, resistor array, 22 microfarad. Okay, I think we're missing both of those resistors, so I'm gonna go with the very last resort, which is to steal them from this board. So we get C15 and C12. Let's do that. I bet we'll find those floating around somewhere. Maybe. So it's always a bit tricky to work on these old boards. Let's add some solder first. And then let's do pump. Get it up like that. There we go. That's C15 from way over here. And then C12, that's the big one. Add some solder first. And desolder it. Comes out. This one is easy to grab onto. There we go. Okay, 2 parts salvaged from the original board. We can always put them back later if needed. And I'm pretty sure later is polarized. Let me have them out. Let's these are old parts. It's always good to see if we can measure some capacitance out of them. My instruments aren't that great, so you may not get super good readings. But let's see if we can get anything out of these. Probably not. No, I don't think these instruments are good enough to test. I'm just getting a few nanofarads reading here. Yeah, I think I need proper capacitor tester to know anything about these tiny capacitance parts. This one goes in that spot, and this one goes here. I think they stay in. Yep, seems like it. But no, it doesn't. Oh, it fell out. Okay. So let's put some blue tack here again. We're not getting much leg through. Really pressing to it. It's always a challenge with these. I have to reuse old parts to hold it in. Maybe I'll do the finger treatment. I'll burn my finger a little bit, but it's okay. Just as to get an initial joint. Okay. Now I just got a tiny bit of solder into the first hole there. Allows me to do them properly. So the other one. Oh, cool. LCR T4 component tester. I'll check it out, see if it's good enough for that type of cap. Okay, so final step. We are just a moment away from testing this thing. We need to install these ICs. Let's start with the LS132. It's this one, it says LS132 right there. Here's the part. LS132M. So notch goes upwards. This is a new component, so the legs are splayed out. I just jole it in like that. It's in place. And finally, the resistor arrays, or the born resistor array things. Hard to see other. Here we are. And we go in here. And wait a minute. They're shorter than the original part, which might be fine, but actually that's since I can't really be bothered looking up exactly what's expected there. I think I'm gonna steal the ones that I have in the other board. So let's just, because they are also socketed here. So I'm just gonna use these new guys. There. Okay, so the only things we don't have in, of course, are the video out, parallel port mouse, serials, expansion slots. Otherwise, I think this is now fully populated. So let's move on to the very last step for today. We're running a little bit late, but I really want to test this. So I don't have a proper harness, so I'll just, I need to screw this back into, very, very rudimentary screwing it back into its little cage. So I need, let's see if I can find screws. It's a little bit of a mess in here because oh, there it is. It was right in front of me. So I'm getting ready to move soon, so I'm just putting everything everywhere. What I usually do is I just put 2 screws in to hold it roughly in place, and then also this cage thing. I put it upside down like this. So I fully expect nothing to have changed with this. I don't think the motherboard is at fault in the first place. It could be. If it is, then we're lucky, I guess. But I'm pretty certain that it's gonna be more complicated than this to fix this system. But we should try. So let's put the very first time we use these brand new slots. Kind of slide it in there. Bam. And then we get the I/O board. Goes right in there. Do the same. Bam. Then we get the memory boards. I should demonstrate it, I guess. So the memory boards are always a little bit more fiddly. There. Second memory board. Alright. So card cage assembled. I will turn on my camera over here again. can find the switch. Over there. Put some stuff out of the way. Probably less than 10 people in the world have built a new Lisa motherboard. Well, yeah, maybe it's 11. I mean, this project it's been out for a year now. So let's see, how can we demonstrate this in the best way? So maybe I should, well, first of all, let's slide this in here. It should kind of pop in. There. Now it's connected on the back. We do want to probably turn this around, like so. We do want to connect the keyboard, otherwise it will complain a lot and be noisy. Then we connect the power. So this will be interesting. And now, since I have one thing that's good to know with this computer is that if you have the back off, the same goes for the front, there is a little switch that prevents the computer from turning on. So you need something. I usually just snip off a cotton bud and wedge it in there just to get, I think that should, which is wedged into the switch there to keep it pressed down. Let's see if this computer blows up or if it doesn't do anything. So in 3, 2, 1. Yeah, did not turn on. So that could be for reasons. Let's yeah. Let's just do the cartridge again to make sure it's well in there. I'll try to like that. Turn the power. It could be the switch back here that's not pressed properly. Actually, I'm gonna try and use. Oh, it blinked yellow. I'm gonna use this plastic tool. There we go. Oh, interesting. So there's something is wrong. I have not seen that happen before. So it's unhappy for some reason. It did beep though, which means probably that some kind of logic started happening. But this is definitely not what we want to see. See if the reset switch works. Oh, yeah, the reset switch works, but the logic just immediately dies. So that could be maybe poor connection with a CPU board or something like that. So let's just take out the plastic tool here to turn it off. Let's just see if we can reseat these boards. I do remember seeing that fuzzy problem, I think, when I was fixing it early on. And I don't recall exactly what that was. So, could be that the boards just don't connect well in there. So yeah, if this doesn't work, then yeah, it's like they're not very deep in there. But anyways, let's try it one more time. Power goes in. We need to wedge something into the power supply again so that it can turn on. Alright, that was it. Okay, so it was just poor connection there. Maybe I should get some contact cleaner into those connectors. Probably the edges of those old boards are just kind of messy. So where did the floppy disks go? I need to try and boot. Works XL. So yeah, let's use the same floppy disk as before. Still doesn't have a lot going on there. And of course I need a keyboard. Continue. Okay, memory board 2 is bad. It's hard to see in the camera. But yeah, it's complaining that the second memory board 2 is bad. So that probably means more bad connection and some more work to be done. Yeah. So let me call it there. I think we got pretty far. I'm quite satisfied. I'm quite happy with how well it works. I think it means that the motherboard is fine. It's just that we're not getting good contacts, I think, between the boards and the horizontal board, no parallel. Sorry, I'm getting tired. The vertical boards that go into the horizontal board. Yeah, so I'll call it there. And thank you all for watching. And if you like to see my playing around flailing with this Lisa, don't hesitate to subscribe. And thank you so much, and have a great rest of your